Hello everyone. So today we are going to understand what is state design pattern. So it is a behavioral design pattern that lets an object change its behavior when its internal state changes, as if it were switching to different class at runtime. So this is also one of the design pattern which comes under the behavioral category. And here we make sure that the object changes its behavior based on the internal state changes. This design pattern is associated with the object changing its behavior when the internal state of its changes. Now let's see what all problems we faced without using this pattern. So let's take an example of a vending machine. So you all might be aware that we are having a vending machine which keeps the items, and we can select the item, and once we have selected the item we can check out it, and once we check out it asks for the amount the item is holding. Once we insert that amount, the item would be dispensed. And let's understand that vending machine and how we can implement that using the state design pattern. So this is like without using this pattern. So first thing is like a vending machine could be in the four state. It could be ideal, item selected, has money, and dispensing. So we will hold an enum state which will have four state in which the vending machine could be. We will also have the current state, like initial start state set as ideal, and which item we have selected. Currently we don't have any item selected when the vending machine is in ideal state, and at that point of time the amount inserted would also be zero. Now let's say a user comes in, and it we have an API exposed to the user. Let's say select item. So here whenever the button of selecting an item is hit from the user interface, this method gets called, and we will pass in the item code, like which item is getting selected, and we will handle, like we'll have the switch statement, like based on whatever the state right now the machine is in, we will respond to the user respectively. So first let's take an scenario of item selected state. So in this state, right now, let's say initially when the this flow started, it was the machine was in ideal state. So let's say when this API gets called, select item, we will check that. Let's say the state was ideal, which is the correct state it should be in. We will mark the item selected with the item code, like whatever the item we are selecting. We'll change the state to item selected state, and we'll print out that this item has been selected, and we'll break out. So if you see here, we in every of the API, let it be and select item or any other API which is exposed to the client, we have to handle the cases. Like here we have handled the scenario, let's say when the state was ideal, what all actions should be performed. Let's say when the case was item selected, what all actions should be performed. Now let's say once the item is getting selected, the user inserts the amount, and hence will expose that API insert amount to the user. And once this API gets called, we will check that whatever the amount has been inserted will set to the inserted amount. Why this case will be executed? Because when the item got selected, we had changed the state of the machine to item selected state, and hence this case would get executed. And we will set the state to has money state, right? And we will say that this amount has been inserted and will break out. Now, whenever the sufficient amount has been inserted, so here we are not looking at the implementation of vending machine. We are understanding state design pattern. So we won't be handling all those checks that is the amount inserted is sufficient or not, whether we need to get the change or not, right? So this is the understanding of the state design pattern and not the implementation of vending machine. Whenever we'll be looking into the LLD of vending machine, we'll handle all those cases there. Now, dispense item won't be exposed to client because technically it should not be, because when amount has been inserted in the sufficient amount, it would trigger the dispense item. So once the dispense item gets triggered, it will hit this case because when the amount got inserted, we change the state to has money state. And here we will change the state to the current state dispensing, and we'll say that item dispensed successfully, and we would need to reset. So like in the entire flow, once the item gets selected, amount is inserted, the item gets dispensed, then the machine should again go to the ideal state. So let's say the new request from the same user or from the new user comes in, we will go ahead by selecting, inserting the amount and dispensing the item, right? And hence we have called reset here. So reset is nothing but changing the current state to ideal state, amount to zero, and the item selected to a blank string. So this is the implementation of the naive approach. Now, if you see in this implementation, for every state, we need to handle the case statements in every API, right? So this is kind of duplicacy of the code, and even this is not extensible. When I say it's not extensible, meaning that let's say there was some new uh, functionality of the machine coming in. So we need to expose new API. It could be XYZ function call. And let's say for that function, we need to again implement all this states. And in the worst case, let's say if new functionality is not getting added into the system, let's say there was one more state in which the machine could be. Then in every API which is getting exposed or which is private, we need to have the case of that state identified into every other APIs, being it select item or insert amount or any other APIs, right? The state, like here we have just implemented four state. Let's say fifth state came in, so we need to handle the case for all of them in every other function. So this like does not follow open close principle. Even it's like harder to maintain, and it's not easier to test if we have any new feature enhancement coming into our system, and it's not easy to extend. So all of this problems were leading into this type of way of writing the code, and hence we have a state design pattern. And now let's see how the state design pattern is implemented. Now what problems we were facing as we saw in the neighbor approach, so it was code was cluttered, right? So all the state related logic is put into single class, which is vending machine class, and resulting into large repetitive switch or if else block across every method. When I say every method is nothing but the all the APIs which would be exposed to the client, and it would be harder to extend. So let's say to introduce new state like out of stock, when the item selected is sold out, would need to update every switch block in every method, right? Because we need to handle the case for every state the machine could be in. And adding this logic in multiple place is also riskier, and like it leads to breaking our existing functionality as well. It also violates open closed principle. Like when can we use the state design pattern? So let's say an object can be in one of many distinct states as we saw, right? Each with different behavior. Each state exhibits different behavior. Let's say when the state is ideal, we can't like have the API of inserting the amount called, right? First we need to select the item, then only we can ask the user to insert the money. So this line means that any if an object can be in many distinct states, ideal item selected has many dispensing other states, and each of the state exhibits different behavior. In that case, you can use this pattern. And if you want to avoid if else or switch statements, that check for every possible state. Like the how we were implementing in neighbor approach, like every state had to be implemented for every function, like select item. We had to implement every state's logic, right? In if else. So if you want to avoid that, we can go ahead with this pattern. Now let's understand its class diagram first, and then we'll see the code. Now let's understand its class diagram first, and then we will see its same implementation in code. So what we have done, like what enhancement we have done in the naive approach. So in the naive approach, if you could remember, the machine could like whatever APIs we could expose to the client. It could be selecting an item, it could be inserting an amount, and then dispensing the item, right? Like dispensing the item, we won't be exposing to the client basically, but it would be like machine's internal way of dispensing the item. Or we can also have an functionality where a user can click dispense or whatever. A button could be there on the machine. Now let's say this is the functionality we need to have for our machine. So, and like we have different states of the machine. It could be ideal, it could be item selected, has money, and dispensing state. Now, what we'll do is whatever the functionality we will have in our machine, we will extract that out and create an interface. Here, as we have created the state interface, which will have all of that three APIs, right? And all of the states which we had for the machine, that will be the concrete implementation of the same interface. So all of this interface, like all of these classes would be implementing this interface, and as it is implementing, it has to define the logic of all of these three methods. That will see in the code how each of the state is exhibiting that. But you could understand it this way that whatever the machine's ability is will abstract that out, so that each of the state, like concrete implementation of the state, would be responsible to give their respective logics there. And we would also make sure that the machine, right, machine would be holding the instance of the state. So current state is nothing but an instance the machine is holding. So this current state is nothing but the state in the machine, the state the machine could be in at any point of time. And this is nothing but the item selected, whichever item you would be selecting, when select item is called. And inserting amount is like whenever the insert amount API is getting hit, the whatever the amount is getting inserted will be capturing that. So now using this current state, we would be invoking the method, right? Select item, inserted amount, and dispense item of the respective concrete implementation. Might be this could be confusing right now, but understand in this way that current state is holding the state in which the machine is at any point of time in our entire flow. Now, the set state method would be responsible to set the state of the machine. Like once we have the item selected, then what the next state it could be in. So that is what the set state method responsibility would be in, right? And reset is nothing but resetting it to like initial state, which we did in the naive implementation as well. And like as this is the class with which the client would be interacting the APIs. So select item, inserted amount, and dispense item would be the APIs which would be exposed to client, right? This would be more clear when we go into the code, but this and you would also get it out right now that how is this set state getting invoked. So if you see here, whenever we are implementing this three of the functionality, we are also passing the context of this vending machine, right? So using this context, it would be able to call this method set state. Now let's see this in the code, how it is implemented. I'll keep this diagram on the right hand side and the code in the left hand side so that it would be easier to walk through. Okay. So firstly, let's see the state interface, how it is implemented. So it is same. We have all of these three methods, and this method will hold the context, and select item will have the item code also getting passed in, and the inserting amount is also passed in the amount parameter. The context will be there in all of these methods: dispense item, insert amount, and select item. As this is an interface, we have the concrete implementation, ideal state, item selected state, has money state, and dispensing state for this particular interface. So all of this are the concrete implementation of this interface. So its responsibility, each of these states responsibility would be to over like implement the functionality. Like you have to define the logic for all of this function calls. So whenever we are in the ideal state, whenever the machine is in ideal state, and let's say select item API gets called, right? So what could be the scenario there? So when it's an ideal state, it will go ahead and select that item, and it will set the state of the machine to new item selected state. Okay. Let's assume whenever our machine was in ideal state and insert amount got called, right? That API got hit. So when I say that API got hit is like the user interface which we have provided the client, if they go ahead and hit that button, so that call will come here. And in that case, we have to give an error that please select an item before inserting the coin. So hence it will throw this statement that please insert an item before inserting the coin. And similarly, if the dispense item got called when the system or the machine was in ideal state, it should say that no item is selected and we can't dispense anything, right? So as I said that every concrete implementation have to define the functionality of all of these three methods. This is how it will implement. So ideal states responsibility would be to, like, whenever select item is getting called and it is an ideal state, which is the correct method, and it should move it to the next state. Here, as I also explained that we are holding the context of this machine, right? So using this, we would be able to call this set state method, and that will set the state, which is this current state, to item selected state, right? We'll see this also in the vending machine how this is working, but this is how this context would be useful, and hence we are passing this vending machine's context here. Now, let's say how the item selected state would work. So now our machine has moved to item selected state. Okay. Now, when we are in item selected state, and let's say if the select API was getting hit, select item API. So technically, it should give that this item is already selected, and whatever the item selected which we have, we should tell to the user. So here in item selected state, the ideal call should go to insert amount. Right? Once we have selected the item, we would ask for an inserting an amount. Whatever amount is getting inserted, we'll set that amount to, like, this set insert will be calling the method which is like using this vending machines context which we are holding. This context is nothing but the instance of the vending machine. We'll be setting this amount, inserted amount, to whatever the value which is getting inserted, and we would change the state to has money state. Right now, let's say we were in the item selected state, and if the dispense is getting called, definitely we can't do anything. We need to tell that insert the coin before dispensing the item, right? So that is what we are throwing here. And now let's say what is the responsibility of has money state. So once we are in has money state, which means that we have selected the item, we have got the money. Now its responsibility is to dispense off that item. So whenever an API dispense item is getting hit, whenever we are in this has money state, its responsibility would be to dispense that selected item, and we would change the state to dispensing state, and we would say that item got dispensed, and we will also reset is nothing but moving our machine to the ideal state, making the selected item as null, and also setting the amount as 0, right? So this everything, this context is useful for calling the set state or resetting. Hence we are holding this instance of this machine, like context vending machine, right? Using that, we would be doing that whenever when we will be in this state. And similarly, in this state, when we have the money, if we are hitting the insert amount or the select item, we should throw respective errors, or we should tell that this could not be executed right now because we have already passed through that two states. And what would be in the dispensing state whenever our system is in dispensing state? So basically, if any of the API would be hit, select item or inserted amount, it would tell that please wait, it's already dispensing. If you want to select new item, you need to wait once the item gets dispensed off. And in this dispensing state, if we hit dispense item, it will say that already dispensing, please wait. This is how the states look like. So now let's see this class vending machine to which the client would be interacting. So as I mentioned, it would be holding the instance of the state. So current state is the state in which the machine is at any point of time, whatever the item we are selecting and whatever the amount we have inserted. So initially we would be setting it to ideal state, right, in the constructor, and this would be null and this would be 0. Now, whenever the set state was getting called from the methods of, like, whenever we were in any of the state, the set state was getting called, right? So that is nothing but this set state. So whatever the state is getting passed from here, so let's say whenever we were in ideal state, so next state which was getting passed what was item selected state, so that would be set to this current state the machine is holding, right? That would be set to the item selected state, right? So that is how this sets to invoke the set state of vending machine. We need to have the instance of this class, as simple as that. And hence we are passing that in every of the state function states which you are implementing. And also this reset is nothing but resetting it to the initial state the machine was in. And these are the APIs: the select item, insert amount, and the dispense item, which would be exposed. And how this works is like whenever the select item is getting called, it will pass in the like whatever the item we are selecting, and in whatever state it would be. Let's say it was in ideal state initially, right? And select item got called. So ideal state dot select item. So it will go ahead and call the select item of the state. Let's say it was an amount, the current state was in the whatever like amount inserted, like it had item selected state, right? And let's say it goes ahead and calls select item, then it will go ahead and call the select item of this item selected state, and it should throw an error, or it should tell the end user that item is already selected, right? So this is how this select item, insert amount, and dispense item would work. So this current state is nothing but the state in which the machine is right now. Using that state, the respective methods, these are the same methods, right? This all three methods in the different states would get invoked based on the state in which the machine is. Now let's simulate this from our main to better understand it. So here, so if you see here, so first vending machine, like whenever we created this instance in the constructor itself, we are setting it to ideal state. If you see here, right? So it would be an ideal state and it would call the insert amount. So whenever it's in ideal state and if insert amount is getting called, it should throw this error, please select an item before inserting the coin. So it would be rejected basically this call. Then like again it we are going ahead and calling the select item. So here it would go ahead and select the item and it will move it to next state, which would be this like in ideal state this method would get called and it will move to item selected state. And once it is in item selected state here, so it will again go ahead and call this insert amount. So vending machine dot insert amount is calling this method basically, this one. But as now current state is moved to item selected state, so the current state is holding item selected state, so it will go ahead and call the insert amount of that state. So this will be called, and it will set the amount, and it will set the state to has money, I mean, whatever the has money state. And similarly it will vending machine calls dispense item, so now the state of the machine is has money state. And when the dispense item gets called, so current state is holding has money state, so has money states dispense item would be called. So this would be called, and here it will set the state to dispensing state, and we will call the reset, so it will reset our machine. And this is a second transaction where the flow is like same from where, this like it will select the item, it will insert the amount and dispense the item. So now let's run this. Okay. So if you see this in the first transaction, it will say that please select an item before inserting the coin. So basically it was in ideal state and it went ahead, like vending machine dot insert amount got called. So this method got called, and as the current state was in ideal state, it goes ahead and calls the insert amount of that ideal state, right? So it goes ahead and calls this insert amount of this ideal state, right? So it throws an error that bits please select an item before inserting the coin. Now when this got executed, the machine was in ideal state. So it went ahead and called for this method, select item, and this current state or select item calls the ideal states select item. So ideal states select item gets called and item gets selected with the whatever item the name was A1, and then respectively this insert amount gets called, so which is like in vending machine we have in method insert amount, like when the item got selected successfully, it changes its state here. If you see, set state to uh new item selected state, so this context dot set state does this. So this it calls this one context dot set state. Where it went? Okay, context dot set state, and it states like changes this current state to item selected state. So whenever and this API gets called, insert amount here, which is present in vending machine. So the current state holding is item selected, and it goes ahead and calls the insert amount uh, function of the item selected state. So it goes ahead and call this one, and hence we get inserted amount, whatever the amount gets inserted for this particular item. And similarly, this dispense works is like here also we are changing the state if you see. So it has money state. So next time when this call comes in, dispense item, sorry, dispense item. So it calls this dispense item. The state right now is has money state. So it goes ahead and calls the function of has money state here, which is this one, dispense item. And uh, like using this, it changes the state using this context, and it will say that dispensing this item, which is the item which we have selected, and it will dispense it successfully is also called, and we will also reset it at the end. Like once you have dispensed, we will reset. So this context is nothing but the vending machines instance. So it will go ahead and call this reset present here. And the second transaction is similar. So this is how the implementation of vending machine looks like in using the state design pattern. Now let's see the key takeaways of this pattern. So key takeaways are like this pattern is easy to extend. So let's say in future we have some new state of the system getting in. So we have to just go ahead and have the concrete implementation of that state, and that would be implementing this interface state, and it will have the respective behavior or the logic implementation for the respective methods, right? So it becomes very easy to extend. We don't have to go ahead and change anywhere except extending and implementing this new concrete implementation of that state. So out of stock or anything, right? It becomes easier to maintain and test, and it also follows open clause principle and single responsibility principle. So every state is responsible for its respective functionality. So we have delegated the responsibilities to respective states, and we are also maintaining the open clause principle. So this is all about the state design pattern. I hope you like the content, and if you like the content, do like, share, and subscribe, and see you soon in some other interesting content. Till then, bye bye, take care, and have a nice day.